Good day, everyone. Welcome again to another session of my tutorial. Today we'll be looking at working with loops. Okay, so we're looking at working with all things concerning loops. And looping, also called iterations. When we say something is looping, it's just like saying it is iterating. That means it's repeating something over and over again. All right, so that's just what those two terms means. Okay, so it's used in programming to perform the same set of statements over and over until a specified condition is met. So we're going to look at three different ways of using loops. So we have the while loop, we have the do while loop, and we have the for loop. Okay. Actually, the while and the for loop does the same thing, but they just have their different style of writing. Why the do while loop has an added unique feature on its own, but when we get there, you will get to see what I'm saying. So for today, for now, let me start with the first one, which is our while loop. You can see the general form of the while loop. So we have the while, the condition that will be there, then its statements. So let's quickly see examples. And before I go on, I would just like to drop an advice that we should actually prioritize sleeping also, because these past few days have not been that strong enough. So it's because of lack of sleep and work stress merged with ALX, merged with also the channel and everything. So let's try to sleep. Sleep is very important. Health is wealth. So we need good health for us to continue studying. All right. So bear with me if my voice sounds a bit low or somehow. So I'm just trying to recover from. All right, all right. So let's go on. Let's see a quick example as regards to using the while loop. So as usual, I'll put my include hash include directive. I put my standard.h file. Um, so first, let's say, firstly, let me just do a small mathematical example in terms of using the while loop. So we'll get to understand it. I have another plan of using another kind of like example. So let me just do it. I think this one will be more understanding when I get to use this example if I do the other a little complex time using characters. Okay, so using while loop. So what I want to do now, I want to print out numbers that will keep adding for me in ones. What I mean is that I want it to be adding 1, 2, 3, 4, 5 like that for me till it meets a certain condition. Okay, so for me to do that, usually whenever I want to work on projects, I usually first imagine how the output will be on my head. So I'm going to use the printf to put that. So I want the numbers to be dropping for me in also in form of a new line, which surely I will then have some kind of variable. Okay, let me just name this variable as I. Okay, so since I've declared I, so I'm going to, since I've used I as my variable there, so I have to declare my I. Okay, so now using the while loop, what the format of the while loop is that first puts, um, the while loop is actually made up of three sections. We have the initialization, we have the condition, and we have the iteration, that's the looping part. So the initialization is the initial number you choose to want to start with. So I want to start my I with 0. All right. Then I will then put my while loop. Then this bracket is where I'm going to put my condition. So I want the condition that I should be less than or equal to 5. That means if it's adding, it should not exceed 5. Okay, so it can stop at 5, but it should not pass 5. So I'm trying to make it as simple as possible. So I'll put my brackets. Then this is where we're then going to add our iteration, which is our I plus plus, which I want to add. So for us to do this, in short, I'm supposed to put this printf inside my while loop block. So I'm going to move this um, initialization condition. Okay, let it print first my output, my initialization. That's, let me put the printf here, then it can add it. Okay, so let's run this code. I hope there is no bug here. So let's run it and see. Okay, so we have, from the beginning, we have our 0, which is initialized 0 that I did here. Okay, so just to understand the concept of how it moves. So first, I is equal to 0, right? Then it goes to the condition. I less than or equal to 5? So yes, it is true, because I is less than or equal to 5. So since the condition here is true, then print I, which is 0. Remember, we started with 0, which is 0. That's why we have the first 0 here. So after printing the I, then add +1 to it. So 0 plus 1 is what? 1. So the 1 goes back to this condition. Is 1 less than or equal to 5? True. 1 is less than 5. Then print 1 for me. Okay, then come back to this condition, add it by 1. So 1 plus 1, 2 again. Go back to this condition. Is 2 less than? So that's how it becomes this answer which we are seeing here. All right, so this is just how to use the while loop. Okay, I don't know why right now, but I feel tempted to show you how to do the same thing using for loop, because you can actually do the same stuff with for loop. You know what? Let's just fly inside that for loop. Since, let me just show you how to use. Remember, I said both of them are quite similar. The while and the for loop actually works like the same. So when we're talking about for loop, its format of writing or its syntax is like this. So we have the for keyword, then we have the initialization at the first part, the condition at the iteration parts. So if I want to modify this time around using a for loop, let me not delete this. I'll just copy. I'm sure no need of, okay, let me just copy and paste. So let me just copy paste this. Okay, I'll just comment this. So that's the while loop now. So I want to modify this font to look like for loop for me. So for me to do that, I'm going to say for, then the initialization, which is I equal to 0, which was what we did. Then use a semicolon. Don't forget, don't mistake it by using comma. Comma means something else, which I'll still explain later. So use a semicolon and then put your condition. Well, that's where it is at the middle. So looking at its initialization, the condition, and then the iteration. Okay, so we have the initialization. So the condition will be I less than or equal to 5, then the iteration, which is I plus plus. Okay, so I think so we won't need this anymore. So we are good to go like this. So you can see the difference between the for loop and the while loop. The while loop look more lengthy, the for loop is more straightforward in a way. So if I run this, you should see the same output. You can see we have the same outputs here, but in a more shorter code. Okay, and let me just mention something here, like when using maybe for loop or while loop, it depends on what you're actually doing. But if what you want to call is a single function under it, just like this for loop now, inside this block of my for loop, I have one single function. So I can actually still choose to remove these curly brackets. Mind you, this curly bracket is very important when you are putting more than one functions. Okay, but if you're having only one function inside that for loop, you can choose to just erase it, or you can choose to leave it. If you want to still leave it, no problem. So I just realized I forgot to put return 0, but well, so remove it, no problem, it will still run fine for you. What to add the return 0. Okay, so if we output this, we should still see the same results. You can see which is still the same result, but this time around in a much shorter way, because we are dealing with one function and no need to put in the curly brackets, so it won't affect the code. But if you are putting in function that is more than one in the for loop, you have to use that curly brackets to make everything seem like a single statement. All right, remember the other statement, we've talked about statement in my previous lecture. So every semicolon makes it a single statement. So the curly brackets makes all those function when there are many statements inside, make it seem as if it's a single statement by the compiler. Okay, so we will not be talking much about that aspect for now. So let me just show you another example that pertains using while loop. Then we go to our do while loop. I'm just sorry, erase. Oh, in short, why am I still leaving? It's not just some of this. Okay, so what we want to do now is still relating to while loop, but I want to just do something relating to using characters. So what I want to do is that I want the user to put in something for me, a character. Okay. So I want the user to put in a character. When I say a character, maybe a letter. Okay. So I want the user to put a letter for me and I want it to print out that letter for me. All right. So I want to use the while loop and to make the condition that way. So that you just also understand that while loop doesn't just only pertains to iteration. I think maybe that is part of its uniqueness. Okay. So it doesn't always pertains to adding iteration by force. That's after it, that's I plus plus aspect. So let's just see how this one goes. So I would like to first start with my printf to imagine what I want my output to look like. So I want it to say enter a character for me and let it go to a new line. Then I'm now advising the person that if the person should enter X, the person will exit from the program of what I want it to do. That's letter X. Remember, we're asking the person to put in a character. That means the person should put in any characters aside letter X. If the person puts letter X, it should take the person like out of the program. All right. So that's what I'm hoping to. So let me just write my return 0. Okay, so enter a character, enter X to exit. Okay. So now what we want to do, I want to then use my while loop. So for me to do that, I'm going to start with, as usual, the initialization part. So I can just use I. You can use any letter you want. Okay. So I want to, okay, since I'm dealing with I anyways, like let's see, let me initialize my I first. Or let me first write the condition part. So the condition part I want to put is that I don't want I to be equal to the character of X. You can notice that character style, that single quote I put there. So what I'm trying to say in that statement, in that condition is that X is not equal to, I is not equal to X. So imagine in your mind now the user puts 1. So that means, I said 1, puts A, small letter A. So A is not equal to X, which is true, right? Then it will run what I asked it to run below. Okay. So if once that condition is true, run this in that I which the user will put. So I want to give it, for me to get a user to input a character inside. So I'm going to use the get char. Don't forget we've talked about get char before. So get char, or the other style of writing is get c. But this one has to argue be a single argument where we can say str in the standard inputs. So that once you put it to still work. So I want to get the character the user is going to put inside the program. Okay, so now after I've gotten the character, I want it to print out that character for me. Okay, which means the character the user will put has been stored, has been assigned into our I. So for me to print it out, I'm going to print it out using my put char. Since we're dealing with characters, we'll put char is for outputting to the screen. So I'm going to put my variable I of whatever this the user puts inside. And another way of putting this, of using this put char, remember the other parts, which is put c. This one has 2 arguments. You can just use this style if you want to still work fine for you. Okay. Okay, so since we have I as variable, we're yet to declare what I is. So I'm going to say int I. All right, so we said why I is not equal to x. Run this. But now let's assume first the user then puts x, that the user purposely wants to exit from the program, and the person puts x. So what should happen? So what should happen will be something you have to put outside of the while loop. Okay. So what should happen is that just tell the user that he or she is out of the while loop. Okay, bye bye. Okay, so let's review. I'm looking at stuff. Initialized I, printf. This one is just an heading part. So this is the condition. Get the user's character. Print out that character for me. If the user puts x, then print out of the while loop. So let's see this. Okay, now let me put in a character. Let me put b, and I'll click enter. So you can see I put in b and it outputs the character which is put sharp for me, the same b for me. All right, so that's just how it works. All right, remember even a character can be a new line. You notice if I click enter now, it will take me to an extra new line after creating the first new line. You can see, so something like that. So that's just another way of doing this stuff. All right. Is there any other thing I need to say? Yeah, I don't think so. So I think this is it about this particular kind of example. Okay, so it's not when it comes to while loop, it's not every time it has to involve the aspect of putting that iteration of things like I plus plus and the likes. Okay, it's not always compulsory. It's we have to do it that way. So that is for the while loop. Let's go to the next part. We have the do while loop. So in this case, this kind of loop puts the conditional statement at the bottom of the loop. So at the bottom of the loop, that's where that's the difference between this do while loop and the while loop. So remember the while loop, always put the while loop at the beginning here of this while part. But this time around, this do while, we are putting it at the bottom of the closing semicolon. So what it does is that in this way, the statements in the loop are guaranteed to execute first, even if it does not match the condition, it will still run first. Okay, before then the condition is tested. Let me explain what that means. Mm. Let me see if I can use that previous example we did. Or can I get there? Can I get there? Let me see. Okay. Um, okay, so speaking of do while loop, so do while loop, I will just have to remove this while and put do. There won't be any condition here, though there will be semicolon, so which is the semicolon. So let me just put it like this. Then the condition part, that's the while. Remember, it is do while. So the while here, this is where the condition will then be. So the condition here, like we said, there was I is less than or equal to 5, right? Okay, that was the condition. So semicolon, return 0. So now let's see the difference with what this answer will give us compared to using the normal while loop. Now, before I run this, I want you to read. I just noticed something again. I'm using letter small letter O here instead of me to use number O. Okay, yeah. So I want to read something again here. Now, this part is talking about the difference between do while and while loop. Now, looking at it, it said first the condition will be at the bottom of the loop, which we've seen. Now, in this way, the statements in the loop are guaranteed to execute at least once before the condition is tested. I mean, before this condition is tested, all these processes have been executed first. Remember, for example, now I'm talking about I start from 0, then print 0 for me, which is the first printf. Then go to the next place, add it by 1, then check this condition, then come back again, print it for me, add it by 1, then check this condition. So it is printing first for me before checking the condition. So now, remember the condition here is that I should be less than or equal to 5. That is, it should not exceed 5. Okay, it should not pass 5. So now it is all good since 0 we first print out, then the addition of it, then enter inside the while loop to check its condition. If I put something above 5, like 5, first let me first put 5. So what will happen is that 5 will print in this place first. Since it's, look at the arrangement, I is 5, so print 5 for me, 5 will print. Then it will come here to do the 5 plus 1, okay, which is what? Which is equal to 6. So since it doesn't meet this condition, it won't bring out, it won't go again to repeat any addition for me. It will just stop here. Okay, so it will just stop here for me. So it will only print this 5 for me. Since it's coming from this 6 and coming down to this place, this is not equal to 6. Okay, I mean, this I here in this condition said it should not pass 5. So that means we can't continue the loop. It will stop here. So it's only this print f, which is 5, that will run successfully for me. That's why we have 5 here. Now, speaking of the case where we purposely increase the number to 6 or 7 or any big number, all right? So which means it is still first going to print that 6 for me without first checking whether this condition, whether it has tell me that it should not be less than, it should not be more than 5. It doesn't care. It will still print that big number for me. Then to come here and add it for me, which is 6 plus 1, that's 7. Then this 7 will come down to this while loop to check the condition, which obviously the condition is not met, so it will stop the loop. But the point is that this 6 has already printed out for me at first. So that's the difference about using the while and the do while loop. So that's what this statement here is trying to say, that in this way, the statements in the loop are guaranteed to be executed at least once before then checking that condition. All right, so that's what I was trying to do to explain that statement well. Okay. Mm. So let's see the aspect of for loop. I think that's it for the do while loop. So we're in the last part of the loop, which is our for loop. We've talked about for loop already. Okay, so let's just see if I can still think of some examples regards to that. Okay, let me create something like a table using the for loop. I still need this. Okay, I can just stop here. So I want to print several things. I want to print 3 tables. Okay, so I want to print a decimal, which is like our own number in terms of C. Okay, a decimal, and I want to print an hexadecimal. This time around, the uppercase version. And I also want to print hexadecimal again, but this time around in lower case version. So this is just what I'm just writing here is just a printf statement, just an English statement. I've not started the main coding. Let me just show you what I'm doing here. Okay, so I just arrange it in the way I want the results to come out in. Okay, so remember what I said, that's how I usually start in terms of wanting to build something. First, imagine how you want the output to be. Then you can then like write it down first, then analyze how you can be putting the steps for it to be following up the way you would want it to follow up. Okay, so I'm going to use my for loop. So I want to loop around, and starting from 0, which is our normal initialization. I just remember that I didn't say something like that, but I will soon say it soon. Concerning as regards to this for loop, like an extra stuff as regards to this for loop. Okay, so I have I is equal to 0, I have I is equal to I less than 16, then I plus, then I want it to print for me now the aspect of the decimal numbers part, so that will be %d. Let me put some space. So the next part will be the part of hexadecimal. Hexadecimal in uppercase times I'm going to use capital letter X. I'm using these format specifiers. Okay. Now this is small letter of hexadecimal, which will be small letter x. So using the printf, I'm going to put each of the variables that describe each of them. So we're still dealing with I for everything. So we're using the same running number. Okay, so the I will run for me from 0 to 15, which is just like still 1 to 16. Okay, when I'm starting counting from 0 and I say it is less than 16, which means the I should stop at 15, right? Which is 0 to 15, and you still count how many numbers are there, they are still 16. Remember, hexadecimal are actually like 16, that is why. Okay, that is zero to 9 and a to f. That is hexadecimal. So since I have only one function here, I'll just put my semicolon here. I don't need to put that bracket since I don't have more than one function within the for loop. So any bug, I guess not. So let's print this. What just happened here? Like, it seems scattered in a way. Let me see. I have my main function int printf with decimal for me. Okay. Let me put a new line here. So once the first row is done, the other row will take it over. So let me run this again. Okay, good. Okay, the spacing is not good enough. Let me just adjust the space. So let's just try it again. Good. So this is what I'm expecting to see. So we have the decimal parts, we have that's the whole number part, and we have the hexadecimal parts using our x as format specifier, and we have the lower using our small letter x. Okay, all of them printing I, which is our variable. All right, so the I keeps adding plus one. That's why we have 0, 1, 2, 3, 4. And it's also adding in the hexadecimal, and this time around, since it's dividing the hexadecimal, which is x, it converts to ABC for the aspect of 10, 11, 12, 13, 14, 15, okay, 16. All right, so that is just it. Um, okay, then I wanted to say something. Now, you can choose to, I think you can choose to remove this I in this part and place it maybe somewhere at the top or something. So let me say something like this. But if you want to do something like this, you must ensure you put that semicolon here so that it will assume that there is actually something here. But I just choose not to put that thing here. I choose to put it outside. So I believe this should give me the same output without any bug. Okay, good. So you can see it gives all the same outputs. But where it's not as if it's really necessary for us to do this thing. So just keep the conversion the same. The weights always will be like this. Okay, just so you don't make things over complicated for yourself. So that's it about for loop. Um, what else should I say about this? Then let me take for example, if we have something like, let me erase this. Shots. Let me erase this part. Something called the null statements. Remember, each part of this is where we are, all these are printf, this part we are putting are what we call the statements, which is what we labeled here statements. Okay. So let's assume I didn't put any statements here like this. What do you think the for loop will do? So let me build this and let's see it together. You can see. So it's actually a null statement. Null means like zero statement, which means it's not performing anything for us. Okay, so we call this a null statement, and that way of writing it is putting the semicolon here. Run this again and see nothing. So let's assume I cancel this. I just run this for loop like this. So still nothing. All right, so I don't know, probably you may need this that knowledge, but well, just know it's just going to run that way. So I think there's also something called, let me check my notes again. A C language also allows you to use comma. Okay, yeah. Let me talk about using comma operator now for combined stuff. You want to do multiple stuff at once. So let's assume we want to do some kind of like addition. So a I want to add a fixed number to another number that changes. So something like that. So imagine adding a fixed number to something that the other number changes. Let's have to say 1 plus 2, 1 plus 3, 1 plus 4. 1 is constant, is still there, while the other number iterates, increases by 1 and then still adds for me. Okay, so let's see how to go about that aspect. And yeah, I just remember something again. We'll be using plus plus here. Mind you, you can also use minus minus. So we've talked about iteration before. I believe we've talked about it in the last video. before this video, then that's the manipulating data. So go back to and then what that minus minus will do. Okay, so that's plus minus minus. All right, that's the post decrement. So it's not as if it's always plus plus. It should be the same thing goes with the while loop. The same thing goes with the for loop. So it just depends on what you are actually working on, what you want to do. Okay, so let's see this program, and this time I want to. I will need two variables since I want to use a comma. So I want to make two things work together hand in hand. So for loop I equal to 0, j equal to 8. So that means I'm initializing the I as 0, I'm initializing the j to start with 8. So as usual, when you are done with the aspect of initialization, put your semicolon. All right. Then what's the condition? Since I want only one part to be doing the aspect of the increments for me, so I'm going to say I plus plus. I want I to be increasing for me in terms of the iteration parts, and also I want this 8 to be decreasing. So yeah, let's play around with using this decrement operator since we've not used it at all. So what this program is saying is that this I will be plus plus, that is 1 0 1 2 3 4 5 6. Oh, look at me, I've never put the condition yet. In case you notice that before me, congrats to you. So I'm supposed to put a condition in between there. So the condition is that I want I to be less than 8. Okay, so since I want I to be less than, that is 0 1 2 3 4 5. I said less. Okay, so that's 0 1 2 3 4 5 6 7 8. That means to stop at 7 rather. Okay, so it will stop for me at 7. All right, so the j part is the negative part, so it is reducing. So 8 is reduced, that is saying 8 9, 8 7 6 5 4 3 2. Okay, so that's just the explanation of this function which I placed there. So I want to print it out. So I'm going to use my printf function. So I want to print out the number, which is whatever I is, and I want to add it to whatever j is, and I want the answer to give me the summation of them, which means I'm going to add two things together, normal addition now. Okay, since I didn't create another variable to do the aspect of the addition for me, I can just simply put the addition here myself inside the printf function. There's ij. This I will take this first d, this j will take this next d, then this last d will then be the addition stuff that I need. So semicolon. Okay, so this is actually a way for me to force it to a single, as in to reduce, for me not using curly brackets. If I want to put this I plus j, maybe if I want to give it another variable, I will have to put that curly brackets. Probably I will just do it after I have finished with explaining this. So I think this is it for this video, for this aspect of what I want to do here. So now this part is our I. Here we'll be doing 0 1 2 3 4 till it gets to 7, then it will stop. So while this one will be reducing its own 8 7 6 5 4. Okay, so in as much as this condition has stopped for this I, it will actually stop everything also. So this last d will give us the output of the summation of both of them, which is this I plus j. So I think that's all good now. So let's build and run this. Oh, I think I need to put a new line. So as it's making, if you allow your system to be running like that way, like that is what we call infinite loop in a way. Okay, so infinite loop means it will just be running forever and to make your system crash. So always be careful when you are doing it with loops, please. Like you can crash your system. All right, as soon as I left that thing now to keep running that way, later on my system will start getting hot and the fan will be running fast, then my system will just off. All right, okay, so let's see. Again, I hope there's no error. New line addition. Okay, let's try this again. Okay, still running that loop for me. Okay, I just noticed this number is not increasing. The I here, I said I is equal to this. I is less than 8, then if I is less than 8, I plus plus. I expect it to add for me now. Is there something I'm doing wrong? We have main function, we have ij. For loop, I is equals to 0, j is equal to 8, I is equals to less than 8, so j, I plus plus, comma, j minus minus. Oh, ah, that's the mistake. I'm supposed to put j there, not I. I placed I two times. Oh, if you saw that, congratulations again. Eh? Remember I said I'm not feeling fine, so I'm seeing double as I am like this. So the first part, we have I equal to 0, we have j equal to 8, we have I less than 8. That's the condition part. Okay, so for this part you say I should be increasing in ones and j should be decreasing. I mistakenly put I for j, whereas I'm supposed to put j here, not I. So if we run this now, I'm expecting to see my original. So this is what I'm expecting to see. So it's not, that's why if you notice there's a part of the program in ALS that talks about debugging. So it help us learn how to find where our errors is. Sometimes there's a time you'll be checking your codes, you'll be like, where is the error? You won't be able to see it. And funny enough, the error is looking at you. That's the annoying part. The error is just staring at you. And the error can be a simple semicolon set, like something basic that you will not even just notice. But if you now maybe share the code to someone else, you know, the person have seen it, you'll not be like, oh. So that is just part of the learning process. Okay. All right. So that's just it about that. So I think let's take one last part as regards to using for loop. All right. So lastly, I want to talk about the aspect of nested loops. So it is often necessary to create nested loop at some point. Okay. So that means whereby we have a loop inside another loop. Okay. So I'll just do a quick example of what we mean by nested loop. A quick example. After that, I would like to create a small program or project for us here, just to sum up everything we've been doing. So what I want to do this time, I want to create two loops, one loop, then another loop under it. Then I will explain how the process of the loop moves, so you understand how the process moves. So I will have, let me start with the first loop, which I choose to initialize as 1. Then we have another loop, which I said is less than or equal to 3. Then we have another one, that's the I plus plus. Now, since I want to put another for loop under it, which means that we have many functions inside it. So since I have many functions, let me create my semicolons. My semicolon will have to be present. Then I'll put the other for loop again under it. At this time, I'll give it another label. So start with J. Let me make it this time around maybe less than. Let's just say less than 5. Semicolon J plus plus. That is, it keeps adding. Okay. So for this part, I can also choose to put a semicolon inside this my inner for loop, but since I'm putting I'm putting a single function, so there's no need for that. So I'm going to put a function here, and now I also want to put a function here. That's for the major first loop. So I put the print function. I'll say start of iteration. Start of iteration percent d of the outer loop, which is like the first loop. Okay, the new line I. So this is just a printout statement, but it is taking the I here. Okay, so to start with that value of I in this our parts in this part here. So that's it for that. Then after it has run, like for example, now we have we initialize I as 1. Okay, so that means it will then go down. The first thing to do is to print this statement. So to say the statement of iteration 1 of the outer loop. Okay, then to go down to this for loop statements. All right. So the reason this I equal to 1 can go down to this printf is because it meets this condition. So it first move from I is equal to 1, which is an initialization, then it checks the condition, is I less than 3, and is it less than or equal to 3? Yes, it's less than 3. Okay, then since it's less than 3, you can do your I plus plus, then you can come to this place. Okay, so that's just what that means. So this other part will put under for loop condition, and this time I just want to say something else. I want to say iteration percent d of the inner loop. Okay, so what we run here is that the first one will run this statement for me, then this second one will come and run this statement also for me. Once this first condition is met, it means this other for loop will execute its own. But you have to notice something here, that this for loop, this inner loop, have to finish its own looping before returning back again to this parent loop. Okay, yeah, let me use parent and child. So this child for loop will have to finish its own iteration. So let me just reduce this number so it won't look too big in a way. Let me make it 4. So this for loop parts, this child loop will have to finish its own looping before it returns back to this parent. So let's just see what we are saying. Let me run this now. Okay, I've not declared I. So I'll say int I, and I also have j. Okay, so let's run this again. Okay, so good. Just so we can see the meaning of the outputs well, let me just paste this place. So let me run this again. Okay, good. So we can get to understand the way the output runs like this. And let me just explain what's happened here again. So yeah, we have I equal to 1 as our first stuff, right? So now since it meets this condition, it will first initialize the I equal to 1 for us. So the start of iteration 1 of the outer loop, which is what is here in our first line, right? Then since the condition is true, it enters this second loop, okay, which is our inner loop or the child loop. Okay, so it runs this one again. This one has I equal to 1 as its own condition. Okay, it will first run the 1 for the iteration 1 of the inner loop. Okay, then to print it out for us, then it's I plus plus, then add it for us. Okay, so since it will add it for us, it will increase it to 2. Then to come back and check this condition, 2 is less than 4, then we run the same statement again in our printf. Then to add it with plus 1 again, then go back up, which is 3. 3 is less than 4. So that's how to continue till it gets to that 4. So when j is equal to 4, which means that meets the brim of the condition, and it has printed out that 4 for me, which then if it does j plus plus, that's 4 plus 1, which is 5, and that 5 doesn't meet this condition. So since the 5 doesn't meet this condition, to go back to the parents loop and continue for where the parents loop stop. Remember, the parents loop first started with 1. Okay, so it will now continue from when it stops. Since it started with 1, so the I plus plus will make it plus 1, which is 2. So that's why we have iteration 2 of the inner loop. Then again, the for loop under, that's the child loop, will run again the same process. So that's how we have 3. And we have 3 of the parent loop because we give the condition to be 3 here. And we have 4 here in the inner loop, but we made it 4 printouts here. So that's just how to do inner nested loops. All right, so it can be 2, it can be 3 nested loops. So it depends on what you are actually trying to work on. So I'd like to close this video with creating a simple basic project of creating a multiplication table. So when it comes to creating a multiplication table with C, so let's just quickly do that. So I would like to first, as usual, just like I told you, first imagine how you want your output answers to look like. Okay, so me, I personally want it to have some kind of like heading. So I will say multiplication table of an integer. Okay, so that's how I want it to look like. So let me make it capital letter. So since I want it to be like an heading format, so multiplication table of an integer, and put a new line So don't forget to put your semicolon to make it a statement. So again, I want you to tell the, in short, no, before I do that, let me just initialize a number. Now I want it to be that it prints out maybe 2 times 1 to 2 times 2 4 2 times 3 6. If you notice, the 2 is constant, the 2 doesn't change, right? So that means I can declare a variable and I'll call that one 2. So that's like saying 2 times multiplication table. Okay, I want you to do 2 times multiplication table for me. So since that 2 will be fixed that way, and then I'll put my for loop for the other one that will be increasing. You know, when I say 2 times 1 to 2 times 2, 4, 2 times 3, the other side is increasing in ones. Okay, so that's why I would then need to use my for loop, which I want the multiplication to start with 2 times 1. I don't want to start with 2 times 0. But if you want to start with 2 times 0, you can put a 0 here, right? So that would be no, we've been using 0 too much for initialization. So just so you can know, you can use any number. So let me just use the 1 now. So, okay, so I have j is less than or equal to 12. I want it to be 12 times, like 1 to 12, you get. So the multiplication, so to be 2 times 1 to 2 times 2 4, 2 times 0, 2 times 12. All right. So final, my iteration, I'm going to say j plus plus. Then put my curly brackets because I'm going to put 2 extra statements here. So the results, which is a new variable I'm declaring again, I want it to be I, which is our fixed I, which is this 2. So whatever I is, I want it to add for me whatever j is. Okay. So let it print this output when it has done that. So the aspect of the printing out, we would have imagined in your head how you want the output to look like. So I want my output to look like, let me just quickly show you a quick demo of how I want my output to look like. I want it to look like something like this. Something like 2 times 1 equal to the answer. So that's how I want. So that means it means I have to customize my printf to look in this format. So what I'm going to say now, I'm going to say %d %d, okay, which will be the I. You get, that means my first I will be this %d. I wrote d. So %d. Then space, then we have x here. So since I'm going to print f, I can just put normal letter x. It won't affect it. It won't even make it multiply for you. So it's just a statement here. So next thing, I have another number here. So which I will name again %d, since they are integers. So %d. And this second d will take the j part. Okay. Then next we have an equal to sign. So I can just put an equal to sign here. Then I put another result, another answer again. Now the answer of this part will now be the result of this. Okay. So that means I can just put in results here. Or just like the way I did the other one, I can put the I plus j inside this part of the results. That means I'll just clean this whole result statement here. So any style you just want to use yours, want to code your stuff, it doesn't really matter. So what I'm saying is that I can choose to erase, like remove this results declaration here and put straight up the I plus j here, and to still give me the same output for me. Okay, so just for simplicity, and that means if I do that, I mean I will just need to remove this curly brackets, because since it only run a printf, a single statement for me, so I won't need this curly brackets. But because of the presence of this result, let me put a curly brackets, since it is more than one statement that is inside the function. Well, let me just leave it this way. Let me just leave it this way. Okay. So I think everything looks fine. Yeah. So let's run this and see our output. Okay, I have not declared I. So int I. So our I is an integer. So let me run again. Oh, I've not declared J. I've not declared J. Okay, J. Okay, good. Let me run again. What's this now? Results. Ah, okay now. Results. Wow. I'm really saying double two. Okay, so let's build this. Good. Oh, no. I don't want it to look this way. I want it. Let me put a new line. I don't want it to look that way. New line. Okay, what just happened in my error? But I think this should be. Okay, good. All right, so let me just build this again. This is how I would expect it to look like. Okay, so that is how to just do a basic simple multiplication table. Now, if you notice what I did here is that I am the one that specified the multiplication value. Like I specified it to be 2 by force. Now you can also make it a user defined value. So the user should be the one to put the number that he wants to use to run the multiplication. All right. And just to explain what I'm saying, like now I forced it to be 2 by force. That's what the output will always bring out. So if I'm a user, that means I will only be seeing 2. So what if I have to do 5 as a user? Using if I want to use your program, which means you have to do for every 2, allow the user to input his own number. So that is where there's a function called scanf. So this scanf can be used for both integers and characters. So it has 2 arguments or 2 parameters. So the first one is the format specifier, which we are dealing with integer %d. Then the other part is the address of the variable that I want to use, which is I. So that and I is just talking about address. You learn about address later on when you are dealing with pointers. When you get to pointers, you know what address means. But for now, just know what printf does. It helps the user to input its own value in numbers. Okay, just like the way we have that put char. That one is in terms of characters. So printf. By you can also print characters with scanf though. Just for us to change this D to C. Now using the format specifier. Okay, so I think we are good to go like this. So let me build this. Okay, so let me give it a number. Let me just say I want it to run 5 times for me. So 5, and I'll click enter. You can see 5 times 1, 5, 5 times. Wait, what just happened here? This is not the multiplication for 5. But I must have forgot to change something here since I made that changes there. Okay, since we have our scanf %d as this. Wait, we're dealing with addition since. What am I doing now? Ah, I'm supposed to change this to multiplication. So I've been not I've been doing addition table since. Why this x is disguising as if it is multiplication. So what I've been doing, just know that what I've been doing previously is addition is addition table. Okay. So now let me not just clean this, just with the addition table. So let me do the multiplication table. Sorry. So I'll do my percent. I'll do my times there. Okay, so on doing my times there, let's check again. Okay, this is our time, so this should be multiplication. So let's run this again. How come I didn't notice the output that time when I was seeing? So this is multiplication. Okay, I've not changed the printf part here. So this one will be times also. So let me use the same x that I used before. Okay, so let me put another number. So this is what I'm expecting to see. Okay, so yeah, so that's it. We have 7 times 1, 7, 7 times 2, 4, 7 times 3, 21, 7 times 4, 28, on and on till 12. Alright, so in short, we've used one stone to kill two birds. So we did the aspect of multiplication table, we did the aspect of addition table, even when it wasn't really my intention. But yeah, that's still cool. Okay, so let me just show you the other aspect of we removing this results here and placing it here to show that to give us the same thing. That is times j I times j, which means I won't need, though you can still leave the curly bracket to still work fine for you, get, but usually it's just not necessary again to put it. So this should still run successfully. Let me put another printf here just so that the user can understand what to do. So I'm telling the user now to input an integer of their own. Okay, so let me run this. Okay, now input an integer. So let me just put a number 4, enter. So it has bring out the 4 times table for me. I just remove this new line so that my output, that is this part where we saw that 4, will be aligned. Like what I'm saying is this. So I can put that 4 here instead of below. So it will look aligned in a way. So if I click enter, it looks better this way. So it's just that new line here I just needed to modify. So I think that's it about this whole of looping. So I believe you understand these aspects. If you have questions, can let me know in the comment section. If you love this video, you can still let me know also. Okay, don't forget to like, share with your friends. All right. So do have a lovely day. Bye.